Good. All right. Everybody ready? Let's get started here.
Yeast. You do it the best.
Now, what I'd like you to do is, I need a lot of interactions, okay? So you need to interact with me, and you're going to say, if I want to know these words, I can't sit here and just look at them. I have to say them. And like tomorrow, when you're in your peer groups, you have to do that. In your groups, you have to say, what is that? That's a solution, or is it, what? A mixture. Wait, a solution is a mixture. And that's what you have to do. Get that? So let's take a look. One way that you could classify matter is this way right here. You start with matter. Anything has mass and volume. And then you say, you know what? If you're matter, you're either this kind of matter or this kind of matter. So what is that? What is that? What are you? You're either this or that. And I know what you're thinking. You're thinking, I'll just go home and memorize this. No, that's not going to work for you. It's not going to work for you to memorize this. Tell me what the difference is between a substance and a mixture. Yes?
A mixture is like more than one thing combined, and then a substance is only one.
Did everybody hear that? Do you agree with that or not? Everybody agrees. Okay, so tell me about H2O. How many things are combined there?
2.
Okay, so we got a problem with what you said. You said this is more than one thing's combined and these are only one thing. But if you're a substance, you're either an element or a compound. But I'm glad we're getting this out now. You see that? What do you think?
There's only like one way to make a substance.
That's right.
Different ways to make a mixture.
To be fancy in the book, they'll say, has a constant composition. Well, to unfold that, he said, there's only one way to make it. How many ways can you make water?
One way.
One, 2 H's and an O. Got that? How many ways can you make a salad?
Many ways.
How many ways can you make a pizza?
Many ways.
How many ways can you make coffee? Many ways. So the main thing here is if its composition is not constant, it's variable. The book likes to say variable composition. What does that mean? It means you can make it many ways. So if you can make it many ways, you're a mixture. But what are the only things that are not mixtures?
Elements and compounds.
And how do you know if it's an element?
If it's made up of one atom.
Not one atom, one kind of atom, right? All right? If I have a lump of gold, there's a billion atoms there, right? But each of those atoms is what kind of an atom?
Gold atom.
A gold atom. Everybody got that? Well, what about a compound?
Chemically, 2 elements.
2 or more,
Elements chemically combined.
but they are chemically combined. That means a chemical bond, isn't it? Is my salad chemically bound together? No. How about salt water?
It's a solution.
Are they chemically bound to the water? No. See that? I think you're getting an idea of how this works now. By the way, if it's an element, another name for this would be called the periodic table of the different kind of atoms. Isn't that right? How many kinds of atoms do we know of? That's it. That's it. Oh, what about water atoms? No such thing as water atoms. Oh, what is steel? Steel? No steel atoms. Oh, wait a minute. Okay, if you're not an atom, if you're not an element, you might be a what?
Compound.
But how do I know if you're a compound? On the test Thursday, how do you suppose to know if it's a compound? If it has not a chemical symbol, but a chemical what? Well, yes, but what do you have? If it has chemical bonds, we call it a chemical formula. What is the chemical formula for water?
H2O.
And what about carbon dioxide?
CO2.
And what about glucose? C6H12O6. Remember that from biology? So they must be compounds because they have a formula. What about air? Air? No, you're not an element. Air, does it have a chemical formula? I don't know what it is. There's no formula for air. Oh, you must be a what?
A mixture.
You must be a mixture. That's right. So now, if you're a mixture, I can look at you and say, hey, I know there's more than one thing in you. I can see it. What are you going to call that?
Heterogeneous.
Hetero means different. And so that's easy to see that you're different. But what about something that is homogeneous? I know you can make it many ways, but when I look at you, I only see one thing. What's that? What do you call a homogeneous mixture? I always ask that question. Always. Always. What's another name for a homogeneous mixture? Solution. Got it? Now, what kind of things can make solutions? Well, could you have a solid dissolved in a liquid? Salt water? That's a solution. Could I have a liquid dissolved in a liquid? I have some rubbing alcohol back here. It says 70% rubbing alcohol. What's the other 30%? Water. Oh, I never thought about that. Can you have a liquid dissolved in a liquid? Yes. Could you have a gas dissolved in a liquid?
Yes.
Carbonated drinks. Carbon dioxide can be dissolved in that water, can it? Could you have a solid dissolved in a solid? Uh-oh. I tricked you. Yes. Now, I'll show you what example. You know the most famous solid solution you've ever heard of is steel. Steel on a periodic table?
No.
Is there a formula for steel?
Yes.
Chemical formula? No. So it must be a mixture. Yeah, but I look at a piece of steel and it looks like one thing to me. So what must it be? It must be a homogeneous mixture called a what? Okay. Now, I will tell you the main ingredient in steel is always iron. But it's iron, alloy. These are called an alloy, isn't it? And it's alloyed with something else. You can have carbon steel, nickel steel. If you have chromium, you have stainless steel. There's over 200 kinds of steel. And you can make 98% iron, 96% iron. You get that? There's many kinds of steel. Yes?
Could you move the paper down?
Okay, sorry. Sorry. All right. Now, I'm going to show you a quick lesson. I didn't do this, but in the world of gold, do you know what you call pure gold? You may ever heard a term that means pure gold? What's the term that means pure gold? 24 karat. You ever heard that? 24 karat is the element gold. Most of you don't have that. Even if you have a gold necklace or something, it'll say like 18 karat gold. You ever heard that? 10 karat gold. Okay, so how that means? Ready? 24 is pure gold. What if you're 18 karat gold?
And there's
What is 18 over 24? 0.75, also known as what?
75%.
Did you know that 18 karat gold is not pure gold? It's 75% gold and 25% some other metal. Now, if the company wanted to use copper happens to be cheap, they can melt them. They melt them and mix them, and then they let it solidify. It still looks like gold. People like that. And why would they want to do that? First of all, pure gold is soft. And if you made a necklace out of it, as soon as you turned your neck wrong, it would snap. Pure gold is terrible for making hard things like a necklace. So they want to alloy it with another metal, and so now you can make a necklace like 18 karat gold. It still looks like gold, and it won't break. Not very easily. Are you with me on this? You can get 10 karat gold. And what's neat about gold is, wow, only 10 out of 24 is gold. They're saving a lot of money, aren't they? Yes, they are. But you know what? It still looks like gold. And sometimes people get fooled. You know, a real gold chain might cost $1,000. And then they say, here, see this gold chain? No? I'll give it to you for 100. All right. But what they might be is, they might say it's Italian imported gold. In our country, you have to be at least 50% gold, or else you can't call it gold. But what if I tell you it's Italian imported gold? In Italy, they don't have that rule. So it could be 2% gold, and you know what? They can still sell it as gold. So I could trick you that way, couldn't I? I could give you a little bit of gold, and you think you're making a good deal, but it's not. All right, you okay with this? So alloys are big, and alloys are all what? What are they? They're solutions. All right, they're metal solutions. All right. So now, what you just saw here, I'm going to draw it in a form without all the words on it, okay? Without all the definitions. Take a look at this right here. This is what you just got done talking about. Let's try it again. Matter can be either what?
Your substance.
Substance or mixture.
And what's the difference between the two?
A substance.
One way to make a substance is more.
There's only one way to make that. There's many ways to make that. I get it. If you are a pure substance, you're either a what? And how do you know if it's an element?
One atom.
One kind of atom. And then what if you're a compound? Two or more atoms that are chemically bonded together. Let's go over here. All mixtures can be separated by physical means. I don't need a chemical reaction to separate these. And so mixtures can be either homogeneous or heterogeneous. And yeah, go ahead. I'm sorry.
I just want to say that it's like.
You what now? Oh yeah. Is anything happening? Okay, let me give it 5 more minutes. All right, now watch right here. Heterogeneous mixtures are easy. You look at them and they look like more than one thing. Look at your skin. Ooh. 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 Okay, that's a heterogeneous mixture, isn't it? But what do you call a homogeneous mixture?
It looks like the same. The seed is different.
A solution, don't you? And again, one of the solutions that'll fool you the most would be an alloy, wouldn't it? But you could have things like carbonated water, salt water, alcohol. Did you know that 100% alcohol will probably kill you? So what they do is people who drink alcohol, I don't know if you know this or not, but beer and wine, beer might be 5 or 6% alcohol, 95% not alcohol. Some wines go up to around 13, 15%. That's about it. And then you can go to this other store and buy the liquor. And the liquor is more than 15% alcohol. You get that? And they have this word called proof. And if you get something that's 80 proof, you cut that number in half, it means 40% alcohol. Every drink, 40% of that drink is alcohol. Wine's only 15. And this is what? 40. And they sell 150 proof alcohol. Oh my, wait a minute. 75% alcohol? That's where you get some dangerous stuff. You get that? You start getting close to 75% and higher, you can actually hurt yourself. Okay, so the people who were moonshiners, and they didn't go to school or anything, but they had their parents or somebody taught them how to do it. If they were making pure alcohol, they might store it in a jug. Have you ever seen a moonshiner's jug? It had like a skull and crossbones on it. Why? It was poison. If you drink pure alcohol, it's poison, isn't it? It'll hurt you. So what did the moonshiner had to teach? They had to be taught how to water it down, didn't they? You had to water it down just right so that you wouldn't kill your customers. And they had to be taught that, didn't they? What were they doing? They took cornmeal and let it ferment and smelly, and all these little microorganisms are turning food into alcohol. Remember fermentation in 9th grade? Remember that? Did you guys have that? Did you have respiration? Alcoholic fermentation? Okay, these little guys, bacteria and yeast, so they break down the corn mash and make alcohol, but oh, my alcohol is mixed with all that other yucky stuff. How do I get my alcohol out? I heat it. But I heat it at a temperature lower than the boiling point of water, because alcohol will turn to steam or turn to a vapor before water. So if you have the temperature just right, alcohol vapors go up to the top of the still. And if you ever see that big loop of copper wire, copper tubing, I mean? Copper, it loves giving off heat. So you put the hot steam in there, and it gives off heat, and it condenses into a liquid. Drip, drip, drip. That's called a still. They call it a still, don't they? And they were getting the alcohol away from everything else. All right. But I want to show you another thing here. What if I had something like this? I'll just pretend this is on the test, okay? Let's pretend this is on the test. And I'm going to put the number 1 here, and a 2, and a 3, and a 4, and a 5, 6, 7. Okay, now I'm going to give you a material, and you got to tell me what's the pathway. Let's try dirt. Okay, is dirt matter?
Yeah.
Okay, 1. Next one.
The mixture.
2 or 3?
3.
Yes?
Heterogeneous.
What do you think? You got it. Let's try another one. How about this? Is it 1?
2.
1 what?
2.
2? Next?
5.
Yes. Back in that. How about steel?
1.
It is matter.
3.
3?
6.
Very good. What do you think? What about 18 karat gold?
1, 3,
3.
and
6.
Very good. Get that? Now, if you know these words very well, I want to do another chart. Now, that's how we'll finish out today. What if I don't build the chart this way? What if I do this? What if I don't ask the question, do you have constant composition? What does that mean? What's constant composition mean?
There's maybe one way to make it.
Right. If you're constant composition, there's only one way to make you. Variable composition. Okay, but what if I don't ask that question right? What if I just ask this question? What do you look like? Of all the forms of matter, things either look what?
Homogeneous.
Very, very good. Homogeneous or what?
Heterogeneous.
Okay, now what? Now how do I separate them?
Homogeneous can become compounds. Homogeneous.
What is this going to be?
Hetero is going to be just heterogeneous mixture. Homogeneous can be pure substance.
Okay.
Homogeneous solution.
What? Help me out here.
Compound and be the compound.
Not yet.
Solution.
Not, well, yes, I like that. I like that, but not compounds here. What's the one you left out?
Pure substance. Pure substance.
Yes. And some books just say substance and some say pure substance. Is that okay? All right, we're not done yet. Now what?
Teachers and students, please pardon the interruption. I need everyone to listen up. So tonight at midnight is the deadline for annual fund as far as the $50,000 additional money that someone's willing to give if we reach 90%.
That's pretty nice for somebody to
So
say
again, tonight
they'll give
is the deadline
$50,000.
for the additional gift of $50,000 for the school. And just wanted to let you know also some of the grades, if you reach 100%, you also get Ozzy's ice cream. And as an example, 6th grade, you need one more family to give in order for you to get ice cream. 7th grade, you need 2 more families. 8th grade, you need 1 more family.
Oh,
So guys, when you go home today, ask your parents if they've had an opportunity to give to the annual fund. If they haven't had an opportunity to give yet, just encourage them to do that this afternoon. They can do it online. and any amount helps, and any amount counts towards participation. Also, ninth grade, you need 6 more people, 10th, 7 more people, 11th, 9 more people, and 12th grade, y'all need 12 more people. Y'all need to step it up at representing the school and being the leaders. And also, non-elected students, please head back to your homeroom.
Also, do you know that the participation, they're not asking for this huge amount, and maybe some of your families did give more, but even if they only gave $5 or $10, that counts as participation. And anyway, the school average is getting up there close to 90%. So think about it. All right, let's finish this. What about pure substance? What are you going to be? Element or... Okay, so now could you do the same thing here if I started numbering these? And we have one more connection. There's one more connection I need to make. Right there. What? Because all solutions are what? They are mixtures. All right, so we have about 2 more minutes here. Let's try, can you try, let's try air. Air? And let's try air up here. Let's do air up here. What do you think about air up here? Does it matter? Oh, yes. Air? 3? How do you know to go 3? Is air on the periodic table? Is there a formula, chemical formula? It must be a mixture, right? And when I look at it, what do I see? That's 6, isn't it? Somebody says 7. Does air look like heterogeneous? Or okay, let's do it down here. Let's do air down here. What we got? 1. This is 2. That's 3, 4. What is it? Wait, all pure substances are homogeneous. I never thought about that. What else? And then it's also a mixture, isn't it? Ooh. Let's do carbon. Carbon.
1, 2.
1, 2, 4, 7, 7.
Very good. C6H12O6.
1,
1, 2,
5.
4, 8. 8.
All right, what do you think? You see how it's not just knowing the words, it's knowing how to compare and contrast the words? That makes sense to you? All right, so tomorrow, what you guys will have a chance to do is I would sit down and maybe practice each of the 4 factor label problems with whoever you're sitting with, okay? And say, challenge somebody, hey, let's do one of these, let's do one of these. And then I spend half the period maybe going over some of these. And don't forget, you do have a homework assignment that's turned in also on the day of the test. So, but doing those drawings should help you too. All right, I think you're going to do really well. I want you to do well on this test, and we are going to get in the lab. I have to watch my timing. I'm going to think about it. Do we do it in the lab next, or do we do the next? I don't know yet. Well, thank you very much. Don't forget, again, the annual fund, if you have a chance, just ask your parents nicely. And
You seen my report card or mine?
wait, no. Wait, you left yours here.
Yeah.
You left yours on the table, and I gave you yours, but I didn't see it when I left and I came back.
Then I guess it's probably in.
I have the other credit for making a worksheet.
Oh, okay, wait. Look at it.
That's also how the work I did.
30 miles an hour. You tell me, ooh, yeah, millimeters per second. Hang on just a second. Look at 4 millimeters. I like that one. And you gave equivalents? Very good. I think these are confusing for people, so I'm gonna redo that one. I think what you mean is, 1 mole of iron equals, you might do that because you can't just say iron is so many grams, but you could say 1 mole of iron equals that many grams. You can do that. Okay. 50 grams iron, how many atoms? Ounces, ooh, 2 centigrams. Wow, is that down? Did you give me the right equivalents down there?
Yeah. 1 pound equals 16 ounces.
Wait, where is that?
In the middle.
Oh, there it is. Ooh, to centigram. Man, that's hard. I like that. I like that. All right. I think you did what I wanted you to do. That is extra credit. That to me, that's really good. I just have to check your work.
I have a question. So you said you had drawings to do. Where are those drawings? Because I was looking at this last night and I didn't see the drawings.
Are they in the book?
Oh, in the book?
Okay, so what I did was, the one day I got the book out and they said, I'm gonna give you a separate drawing. So there's 7 drawings with captions. And then also on the computer, I put down there's 7 drawings with captions. And so, for example, and it's gonna take less than a minute. Here's the first one. It says table, and I wrote them down on the notes. A table 2.1, you simply do that, and there's no caption for that one. And then you go, the next drawing is not till here. That's a drawing, that's a drawing, that's a drawing. You draw the drawing, label it, write the caption. You weren't here that day? Did you skip a
I
day?
don't know.
Here it is. See this right here? The first day I did this chapter, I actually wrote them out right here. Do you want to take a picture of this?
Yes, sir.
Okay.
Does it say the page number?
Say it again?
Does it say the page number? Take a picture too?
Yeah. So what happened is, because some people weren't as sharp on the factor label, I decided to make this into 2 separate homework to give you help your grade a little bit. You still have to do them though.
Thank you, Mr. P.
Okay, you're welcome. You playing basketball? Great. Yeah, great.